Okay, so Michael Abanasa are not here. Really? Since when does class start at 4:20? Since when does any class start for us at 4:20? Anyhow, no problem. Arifin, you're here. Hassan's here. Sanjeev. Hi. Sebastian. I love it. Jerwin. Hi. Sorry, I have like partials here. Daewoo. Hello. William. Thank you. Raymond. Hello. Bilgun. Zero. Hi. Gabriel. Okay. Samuel. Ivan. Brian. Vi or Vi? I don't know what would you prefer me? What name would you prefer to go by? Vi or Vi? If you're even here. Okay, he's not here. Okay. Vi? Okay. Bye. EJ? Hongwei? It's Honglin, but thank you. Sam? Or Sadit, sorry? I swear you're gonna kill me with this name thing. Hold on. So.
Miss, just go with Sade.
Yeah, I know, but everywhere it's Sam. So
okay then, go with Sam. I don't know. Which one is it?
Whatever. It doesn't matter. Ran? Michael? Is Michael here yet? Oh, hi, Ran. Yes, thank you. Trong? And Valeria? Asya? Hongmin I already saw. And Hassan Safan I already know is here. Reniko? Okay. Shubham? Carla? Okay. James is coming still. Prem? Oh, James is here. Hi. Welcome. Prem? No. Maria? Hi. Kiefer? Ray? Yes, yes. You asked me to use Ray as your first name. Is that, or do you want me to go with Ray Feng? What would you prefer? Ray Feng? Okay. Okay, Hayden? And Lushui. Okay. Excellent. Is there anyone I did not call? Yes, I did, Chong. Yes, no problem. Hayden, you're fine. Don't worry about it. Okay. So, who am I giving presentation rights to for your presentation, Hassan? Okay. So which one? Hassan Aziz or Hassan Safwan? You guys can use your mics now. You're gonna speak anyways. Somebody make a decision.
Aziz, you want to do it? Yeah.
I'm gonna give Safwan. I'm gonna give it to you. Okay.
Okay, sounds good.
Okay, so you're presenter now. Remember, when one of you is speaking, please, the rest of you, everybody, put yourself on mute. Okay. Hassan, why don't you go ahead?
Sorry, Prof. Am I the first one or the second one?
Hassan Aziz, you are not.
Yes,
you are not presenting. Hassan Safwan.
Thank you very much.
Okay, so
I will be the first.
You'll be what?
The first?
I don't know if you'll be the first. I don't know.
Yeah, okay.
Will you be the first person to speak? I don't know. That's between you guys. Should have this all in plain. I don't know.
Okay.
Okay, I'm gonna mute myself. You guys take it over. Good luck. Okay, and you have your time here. So I'm gonna mute myself now.
Okay. Hello, everyone. Today, Group 2 will present the subject concrete detailing, formwork, and rebar drafting practices. Simple definition of concrete is, it's a heavy rough building material made from a mixture of cement, aggregate, natural sand, crushed stone, gravel, recycled concrete, air, and water that can be sprayed or poured into a formwork. And here, I will explain what formwork is. Next. Formwork is a temporary structure used as a mold in which the concrete is poured in to create concrete slabs and other structure. Formwork holds a freshly poured concrete until it's strong enough to hold itself. While the concrete dries up in the mold, scaffolding and other false work is used in the meantime to support the framework. Some things that need to be taken into consideration when using formwork: the sides and base should be able to resist the pressure of wet concrete after the concrete dries up and can hold itself. The formwork is removed, and sometimes the removed formwork can be reused afterwards. Next. Material and what determines them. Next. As an ideal goal, material has two things. Materials for formwork should be easily obtainable and reusable. The second, the material should be able to withstand the weight and be resistant to distortion when exposed to the concrete and other elements. There are many kinds of material. First, timber. Timber. Traditional formwork use timber wood as the main material, mostly used as a bracing member and in commonly a valuable material, which has excellent strength, weight, and cost factor. Timber forms have limited usage and short lifespan. Second, plywood is a special type of timber, manufactured wood, used especially for shading, contact face, as in provides a smooth finish. It reduces the cost of building as the smooth surface. It provides save up the cost for smoothing the concrete afterwards. Plywood gives more reuses compared to timber, but it still has a short lifespan. Next. Steel is very costly but has indefinite potential for reuses. It is more economical to use as it has a long lifespan. Also, they provide rigidity and strength compared to other material. It is used for heavy formwork structure like a bridge formwork. Although there are a few problems with the steel as a steel sheet formwork, it is prone to corrosion and rusting. Also, they are harder to cut and resize since they are manufactured in a standard size, which bring difficulties for irregular dimension. So it needs a certain level of maintenance and should be oiled after each use to avoid corrosion and rusting. Aluminium is mostly used for a prefabricated formwork, which is created on site and is require less handling. It also requires less support and ties. It reduces the handling cost since it has a lighter weight. Aluminum alloys are used for corrosion resistance and extra strength. Next. Plastic. Plastic is best suited for low cost, repetitive structures. It is light in weight and very durable and can be reused many times. Can be reinforced with glass, but cannot take much load compared to the metal formwork. Next. Structure using formwork. Structure vertical arrangement. Next. For structure like column and footing and such, it consists of vertically arranged molds. Ideally, it should allow a quick assembly. Material for column vary depending on the shape of the column. For wood and steel is often used with the square and rectangular columns, but steel and fiber reinforced plastic are available for round column forms. Next. Horizontal arrangement. For structures like beam, ceiling, and slab, it consists of bottom and two sides. Basically, I can say a three-side box. Next. This is a sample of one of our bridge in Canada. Next. This is a sample of an example of a bridge of formwork, a bridge assembly. This is a very short video. This is the scaffolding. And they try to assemble the formwork. And this is the plywood, because we need a very fair face with no finishing. They put it on the scaffolding. And by this way, you can put the concrete. After is dried up, they remove the framework. Thank you very much. The second part of formwork with Harshal. Okay, go on.
Yes, thank you very much, Stefan. So formwork requirements, you could also say formwork objectives. Let's start with the economy. Economy basically means cost. For example, like Hassan said, there are different types of materials, steel material, plastic, wood. So the contractor should know which material to use and which is better for them. For example, steel, when you go to buy, is very expensive, but you could keep recycling many times as not as much as wood. But also the contractor should see that do you have space for storage? So these all factors need to be considered. Next, quality. Sorry, no, just go back. Yeah, quality. So when creating a formwork, the contractor should ensure that the shape is not changed. And when the shape is changed, it could reduce the strength of the column example, and it could lead to a structure failure. Safety. Safety is very important because, for example, a slab formwork, the workers are working on top of it, pouring concrete, and if the slab formwork fails, the workers fall down a steep hole and it could lead to death, so other long-term effects. Next. Yeah, this is a short clip showing studying online how it looks like. Yep. So this basically shows why safety is very important, and yeah, and why. Let's analyze what was the cause of formwork failure. So first one, inadequate bracing. So as you could see in the picture, the load at one side is overloaded, which allows the bracing to fall, and it leads to pressure on other bracings, which is unexpected, and it could lead to failure in the structure. Next. Inadequate control of concrete placement. So this is very important stage of the concrete formwork when pouring concrete. As you could see, the cases of 85 cases when the formwork has failed, and you could see the most is 49% is when during the concrete pouring. So the contractor should ensure that where they are pouring the concrete, they are providing extra bracing, and the flow is not that high to shake the bracings to lead to a failure in the system. Next. Yeah, vibration and impacts. So in a construction site, there are very heavy machinery working, and which could cause the bracings, example, to shake up or it may fall, and which could lead to unexpected pressure on other bracing. And also impact when the workers are working, they could hit on a bracing and one bracing could fall over. Without them knowing, there is a weakness in the system, which causes failure also. Next. Sorry about this. I think someone changed the theme. We were working online, so yeah, it's not visible, but I'll tell you. So the next was unstable soil. The unstable soil, as you could see in the picture, the soil is very weak, and when the load is applied on the bracing, the soil sinks and it causes deformation at the top, which is not very good. So before the construction, they should inspect the soil if the load will be able to the soil will be able to take the bracing from the load. Yeah, next. Yeah, also here someone changed the theme. We are working online. Sorry about that. So the next was lack of attention to formwork details. This is usually when the contractor is inexperienced, lacks knowledge, or just carelessness. So when this happens, this is usually when like a small mistake like not tightening the formwork properly, miscalculating the load of the concrete when pouring. So this is very important work. Like I said, is safety related. So the contractor should ensure that no details is left over and should review it again. And the last one was improper stripping and shore removal. The contractor again should ensure that when removing the formworks and the shores, the concrete is cured properly and is not yet wet or is not strong yet to hold the structure. So it should be ensured that the concrete is cured properly, so they could remove the shores and stripping safely, so that there is no deformation or sagging, causing a failure in the structure. Yep, next. I'll ask James to take over.
Hello? Okay, let's start off with the drafting practices. One of the most important parts of construction has to be the planning and drafting. Would you agree? Planning the location, the cost, and what were you building? Next slide, please. That is why we have design software to help draft up a plan and create blueprints for the rebars. And depending on the designer or the engineer, is what program they prefer. This is a list of the bunch of programs: Bentley's own Pro Concrete, ReboCAD, and the list goes on. But one of the most important ones, or one of the better ones, is Revit. Revit is a powerful tool that allows designers to create a, a vision in 3D. BIM Revit allows every member to be able to make easy changes in the program for the project. Almost like Google PowerPoint or Excel. So like you could see our PowerPoint theme has been changed by one of our individuals by mistake, and that's what happens with Revit. If you delete a bar, it will also give you a count of how many bars are on in the project, or if you add a bar as well. And once we know the amount of rebars that we require, we can then go on to select the types of rebars. Next slide. So there's 4 main types of rebars. And depending on the designer, or depending on the design, is what we use. There's advantages and disadvantages to all 4 of them. So what are they? Next slide. So black steel, one of the most commonly used rebars on the field. Why? Because it's cheap. They have great tensile strength. They can be welded or bent on site. And the only disadvantage to it is that it corrodes in the concrete. This is very bad because when rebar corrodes, it can cause cracking and breaking of the concrete. So to prevent this, they usually add an anode next to the rebars to deoxidize the bars. But this is also an extra cost. Next slide. So someone invented the epoxy-coated rebars. This was supposed to solve the problem of corrosion oxidization. Well, it does, but I guess you're asking me, why do I have it as a disadvantage? Well, epoxy-coated is just black steel that is painted with epoxy. When placing the bars and installing the bars, they can get nicked or chip the epoxy off, which will lead to corrosion. Fun fact, MTO, even though they have plenty of suppliers of epoxy-coated rebars on their DSM list, they are gearing away from this type of rebars. Next slide. So here comes glass fiber reinforced polymers rebars. That's a mouthful. They don't corrode, they're light, can be cut on site easily, they're strong, they have a long lifespan. So what is the disadvantages besides a really long name? Well, GFRP, as it's known on the field, it costs a little bit more than black steel or coated steel. You cannot bend it on site, so whatever you order is what you get, and can be brittle. So imagine pulling a rebar tensile force. That bar, once it reaches that max force, it will stretch and will continue stretching and become weak. Now in the concrete, when that becomes weak, you could see sagging, and you can notice that something's wrong with the bridge. Well, with GFRP, once it reaches its max force, it will just snap. And even though it is really strong material and the max is really high, if it does fail, the design of the bridge, it will be a short window before it snaps. Not like any rebars. Next slide. So here is the Cadillac of rebars. stainless steel. Advantages: does not corrode, extremely strong, can be bent on site, great tensile strength, but of course, it is the most expensive, almost 10 times more of black steel. I guess you get what you pay for. Next slide. So when rebars come on site, there are markings that you should know. There's the mill markings that are on the top. I guess you can't see my pointer. There's mill markings on the top. Yes, whoever's pointing, that's perfect. And then right next to it, you will see the 15 mils that will indicate the size. The SS indicates the stainless steel. So what does this symbol mean? Well, this symbol from the mill, this is actually a Mana rebar. This picture I took myself. And they're located in North America. Those little two dots are a location where their location is. Now, to figure out where what kind of rebars you are looking at, there's a link here provided, and again, because of the theme, you can't really see it on the bottom. That will take you to the designated sources of materials, the DSM list, that MTO allows. So the DSM list is actually a list of approved material that MTO allows on their projects. Okay, next slide. Enough about rebars. Let's talk about placement of rebars. Next slide. I was fortunate enough to be able to go onto a precast site before COVID, obviously. And here you will see how workers are placing the rebars. One by one, by tying them, they will use all sorts of tools and all sorts of different types of rebars, like dowels. This is a spacer on the right here, where with the measuring tape there. And what you're looking at here is you're trying to create like a concrete. You're trying to make it spaced out enough so that the concrete covers the whole rebars itself. This picture on the left here should look familiar. It is actually one of our exercises, exercise B, girders. You can kind of make out the shape there. So what they do is they form the rebars first, and then they will put it in a mold, and then they will pour the concrete after. Next slide. And here's a picture of the placement of the rebars on the field. This is actually the QEW in Fort Erie. A colleague of mine that took these pictures. Here you could see the spacing of the rebars. You could see the thermocouples along the GFRP rebars. You could see the covering and how the concrete is being poured as well. Yeah, thank you. Next.
Hi guys, I want to talk about types of concrete. Next one, please. Concrete is composed of coarse aggregates, cement and water, and they create construction materials when mixed together. And these ingredients should usually be mixed in a ratio of 1 part cement, 2 parts sand, 3 parts gravel, and half part water. Next, please. And there are many different types of concrete that they can use for bridges, pre-stressed concrete, reinforced concrete, lightweight concrete, and precast concrete. Next one, please. Prestressed concrete is created using a special technique like reinforced concrete. It includes bars. When the concrete is mixed and placed, and these bars are placed at each end of the structural unit where they are used. And prestressed concrete is used to build bridges, heavy loaded structures, or roofs that have long spans. Next, please. Reinforced concrete. This form of concrete is widely used in industry and modern construction. And the strength of reinforced concrete is aided by placing wires, steel rods, or cables in the concrete before it sets. Buildings, bridges, and roadways rely on reinforced concrete. Here an example of reinforced concrete design lab test. You can see, okay, please play it. Okay, thank you, Hassan. Next one, please. Lightweight concrete. Lightweight concrete is a kind of concrete that has a density of less than 1,920 kilogram per meter cube. And a lightweight concrete is created by using lightweight aggregates. And that aggregates are ingredients that add to the density of the style of concrete. These lightweight aggregates include natural materials like scoria or pumice, artificial materials like clay and expanded shales. Common use for a lightweight concrete include creating long spanning bridge and decks and building blocks, and also be used to protect steel structures. Next, please. Precast concrete. Precast concrete is created and cast in a factory according to exact specifications. Precast concrete units are then transported to the site and assembled. It is used for bridges, concrete blocks, precast wall, staircase units, and poles. And the advantages of using precast concrete is its speedy assembly, since the units are manufactured in a factory. They are of a very high quality. Thanks, guys. And
Hey guys, so I'm just gonna be talking about precast versus cast in site. So precast, it's usually built in a factory. These are temperature-controlled laboratories where temperature is adjusted for optimal strength. Usually in factories, the concrete tends to be stronger because you eliminate the worksite complications. For example, at a worksite, you would have fluctuating temperatures, changing humidity, sun exposure, or no sun exposure. All these affect the quality of concrete. Um, More so in a factory, they have special tools to create better end results. One common tool used is a shaker. I don't know if that's the actual terminology, but what it does is it just vibrates the concrete to cause air bubbles to escape easier, ultimately becoming more dense and stronger. Um, but the drawbacks of precast are that their materials need to be transported and carried onto a site. Um, Usually with a crane, this adds some complexity to projects. Here I can show you a picture of them arranging a bridge. Though you still need to transport the concrete to cast on site, it's in its liquid form, which makes it easy to pour on site. Though the concrete is poured on site, it needs contractors to prepare the formwork and be ready for any issues. Because as soon as it's poured, it starts to dry. When poured to uh, sorry, when poured to create a floor, the leveling has to be precise with no lumps or dips along the concrete. The biggest drawback of casting site is the curing time. This can delay work or other progress while waiting for the concrete to cure. Next slide. So admixtures. Admixtures are exactly as you hear it. You add to the mixture. When mixing concrete, these admixtures are added to alter the properties and functions of concrete. There's 5 common admixtures used in concrete. Uh, the first one is super plasticizers. These increase the strength of concrete and increase the workability. So as you pour it, it's easier to work with. Second one is water reducing admixtures. This is used specifically to just reduce the water needed for concrete. This causes the concrete to have a low slump, causing improved concrete properties. The third one is accelerating concrete admixture. This is used to speed up the curing process of concrete. For example, if concrete gets to 50% of its strength in 14 days, adding this can get 50% in 7 days. Again, this is just an example, theoretical. This type of admixture is used in colder climates, such as, I guess, Ontario. The fourth one is air entraining admixture. This specific admixture plays a complex role, especially in colder climates, such as our own. The intended purpose of this admixture is to create gaps within the concrete to avoid cracking due to freezing and thawing. Problem with these gaps is concrete is very porous, which is ultimately causes reduced strength. The last one I'm going to be talking about is set retarding admixture. This is mainly used in warmer climates. What this admixture does is the opposite of accelerators. It slows down the curing process. The reason this is used is because when concrete is curing, it produces a lot of heat. This heat dissipating causes thermal cracks. To avoid these thermal cracks, we allow the concrete to cure at a slower pace. I think that's it. These are references. That's it. Thanks, guys.
Thank you. Does anybody have any questions for? Here we go. We got some questions for you guys. Okay, so Trong has a question. Michael has a question. There's a whole bunch of them, so I'll leave them for you guys to respond. But thank you very much for this presentation, and then we'll get started. So whoever wants to take it away from your group. So first question is, do wall and column formwork get erected at the same time? Group 2. Come on.
Yes, I will answer this question. Okay, we can do it in the same time. Sometimes there is a join between the wall and the column at the same formwork. It depending on the design and it depending and the dimension of the column and dimension of the wall. Okay.
Great. Thank you, Hassan. Next question. Is there any solution to secure various prefabricated components?
I will answer. I don't know. I don't see this. I will answer. What is the difference between the formwork and false work? Okay.
Okay, go ahead.
The formwork is this like the case, which is the mold of concrete, put it inside it. But this case needs supported, needs something like scaffolding and other parts of the formwork. So when we put the formwork, we need to support it with many things. For example, if we have a slab, we can put the slab and put the concrete on it after we put the scaffolding and to support it, not to fall down. That's the difference between false work and false work and formwork. Okay, this is the answer of this question. What will hold the slab formwork in the first video?
Yeah, I'll answer that one.
What will hold the slab formwork in the which video? I don't.
Yeah.
You mean the
Hassan, it's not you. It's Harsha will answer. Harsha will answer.
Okay. Thank you.
Okay, so the slab formwork in the first video, I think you mean the one which is falling down, the video I showed. So you could see there is a lot of shows, the wood shows, which hold the slabs, the formwork. So when they are pouring the concrete, the load goes to the shows and to the ground until it is cured. Yep.
Thank you. Okay, so we missed the question here. It says, is there any solution to secure various prefabricated components? Secure them to what? What do you, I'm assuming either somebody has a question or maybe to get a clarification for this question from your group. That would be amazing.
Okay.
While transporting.
Sorry, Prof. There is a question here from Dayo. Is it available to reuse the plastic form like wood and steel? Oh, there's many questions. That's why it's gone. Okay.
I know. That's why I'm saying them one at a time so we don't miss any. But I know you want to skip to yours.
Yeah,
I know, but if you can just, I understand. Don't worry about that. I will say the question, just whoever is in your group to respond to the question I'm asking, and then we'll kind of move on, okay? So the question is that Vi was asking was, while transporting, is there a solution to securing various prefabricated components? So I'm assuming that is for Hassan Safwan.
Oh, I mean, usually it's just so when it's delivered on a truck, it's usually just tied down. If that's, I'm not really understanding the question. So how do you transport it while it's secured? I'm guessing you mean like on a truck, it's secured on a truck as it's being.
Yeah, it usually comes on a flatbed and you just move it, right? He's talking about also the storage and handling.
Avoid impacting. I mean, they're usually just held in place, shoving.
They're usually held in place by these like big
straps, right?
Straps,
like just,
exactly. And then when they're brought to the site, they're either left for a bit, not too long on site, and they're used. But once they're prefabricated, once they've already been, I guess,
they're pretty strong.
Exactly. Yeah,
so
because remember, they're going to be out in this air all the time, so they're already created for it, right?
Yeah. So I guess that answers that question, and they're not brittle anymore, and they're because they've been cured in a factory.
Yeah.
Next question, I guess.
Sorry.
Okay. Yes, James.
Oh, I can just I can elaborate a little bit more.
Sure.
Just normally when they're made in factory, they're placed in like a field of land. I was trying to find a picture here. And like there's multiple different types, and then they're then they're eventually, when they get transported, they're put on a flatbed, like you said, strapped down, and then they're taken to site, and then a crane will pull it from the flatbed and place it.
If you have a picture and you want to show it, you are a presenter now if you want to, James, if you have one, anyways.
I'm
If you don't, that's
trying to
okay.
look for one. I
Okay.
have so many. It's just, yeah, I had
Yeah.
one. I know I saw it yesterday. If I
That's
find
okay.
it, I'll try and
Let me know.
share
Yeah.
it.
Perfect. Thank you. Next question. I think we already answered the next one. Is there anything? Okay. Forward. Okay. Can you? Oh, Hayden asked, can multiple floors be formed at once? Or was that already answered? I'm not sure. Hassan Aziz?
Sorry, I don't hear the question.
Sorry, can multiple floors be formed at once? Did you already answer that question?
Yes, I already did.
Sorry.
But there is a
I
question
was trying to read. Yeah,
I
from
didn't
Dayu,
answer.
is it available to reuse plastic form? Go ahead. You can go ahead.
Yes, we use it. We use it especially in the biggest span and in decoration. And this is like they consider is as finishing. They don't need to use finishing for that kind of slab. And they use it many times. It's like it's not like the wood or other things. They use it many times, and it's very economical things and very beautiful things, especially in the architectural field.
Thank you.
Welcome.
Any other questions? Great job. Okay, I do have a question just for curiosity. James, I haven't been on site, to be honest, when things have been done with rebar. How long does it actually take to place rebar of that magnitude, for a bridge? Like how many, what's the length of time that's left for rebar placement? Do you have an idea? I know you, if you don't, it's okay. But.
It was a colleague of mine that did that.
Oh, okay.
Yeah, it wasn't me, but I think it all depends on the manpower.
Oh, for sure.
And it all depends, and there's a lot of planning
Okay.
involved in that.
Definitely. Yeah, and that part I know. I just didn't know how long it actually took for the process of just placing rebars at on site. Okay. I think we're good. Okay.
Yeah, Miss,
Well, thank you guys. Sorry, go ahead.
yeah, I'd like to apologize for the theme change and some of the content was not visible. Like the one we submitted, I think that was a good one. So yeah, just like to apologize for that.
Well, thank you. Okay. Well, great job, guys. Thank you. You did good. How about that? So let me. All right. I'm assuming no more questions. Okay. Okay. So let's go ahead, take a break. Okay. And then we'll come back, and then we're going to use the rest of the period to work on your project. So if you have any questions, we're going to have our teams meeting up. Okay, and then that would be kind of it for the rest of the period. Okay. Yes, Arifin.
Sorry, Professor.
Yes.
I know it's just off topic, but have you checked an email that I sent to you about the meeting for BYD?
Not this class. For not this
Yes.
class.
Yes.
Okay, so we'll talk about it later. But I haven't. I've been crazy busy for the last 24 hours. So that's why I told you guys I'll be getting back within 24, 48 hours.
Sure.
So I will be looking at all my emails tonight.
Okay, thank you.
You're welcome. Okay, so break, and then we'll come back, and then we'll kind of start working on our project. If you have any questions, I'll be available for that.
Sorry, I have
Yes,
one
James.
picture if you want me. It's
Oh,
not.
go ahead.
It's not on a truck, but it's like let me see if I can share it. It's just how they're lifting it up.
This is from in the plant to they're going to put it into their like open air space area, right? From there.
Exactly. Well, this might actually go into their curing room first, and then
Okay.
from there it will go to an open space.
Okay. So here it is, guys. That's precast. Thank you. Thank you very much, James.
No problem.
All right. Okay, let's take a break. I'll see you guys in 10 minutes. Sorry, guys. I was okay. We're back to the project. Okay. Does anybody have any questions for me with regards to like a general question for me with regards to the project? Sorry. I know I'm gonna open up Teams in a second. For Teams, just give me 1 minute. I'm gonna open it up. I'm still having trouble with downloading that package. I just didn't get to do that. So I'm going to do the hatching next class. If you guys can do it, go ahead. Yeah. By the way, is Josh here? Oh no, Josh is not here. Sorry, it won't allow me to open up my. I hope that's right. Okay, good. All right. So, did somebody start a Teams meeting or should I? So, what I'm going to do is just to not. I'm gonna mute here and I'm gonna have any questions that anybody might have. I'll be on Teams. If I find that it's something, you know, general, then I'll come and explain it to everybody in class, okay? Does that sound good? Like every time I'm just going to send a reminder. Cool, I love it. Oh, yes. Okay, so Teams. And okay, I opened up a meeting. Whoever wants to join in there, please come. And Hassan, Safwan. Oh, here you are. Never mind. Give me 1 second, guys, and I'll be right with you, okay? In Teams. Yes, James, I know, but as I was saying, the hatching is not working for me still, so I'll show it in the next class. But thank you for reminding me. Okay, guys, I just want to discuss rebar placement because I have a few questions about rebar placements over the last few times. So I'm going to share my screen here. So when we're placing rebar on a drawing, you don't always, this is an older drawing, so it has a lot of the rebars that you're seeing, but usually you do not. I want to see the one that we have. Usually you do not see all the rebars. You just see one, and you would say, it would tell you that, you know, the spacing is this much with, with the type of rebar. That's how you would see the rebar on site, on a drawing plan. So I'm just going to show the one of the example that I wanted to show here. Okay, so here. Okay, so here it says, oh no, this one's not it. Okay, so here you're going to look at this one, and you're going to see where it says here 15 to 20 M's at 200 top, lower. Okay, so when we're only showing one, we don't need to show them all. So what you do is it says that from here to here, there is this type of rebar, which is either 15 or 20. At the top, you're going to have them placed at 200 millimeters apart. So you just show one. You're just showing one example, and then they place them on site. Okay, that is why you are only going to show me one on your project, part D. Okay, I hope that clarifies that. But in reality, when you're even at at work, so at work you would, you wouldn't even need to place all these, dot rebars here too. You would just show a few on one side, and you say typical, however many 620 M bars or 1020 M, whatever it is, right? Or and just show a few of them and just say typical, right? Typical on both sides. You might show just a couple here, and then that's it. At the top, you would show the same, a few here, maybe a few here, same thing at the bottom, and then that's it. That's how you show rebars. You don't always show every single one. It would overtake the drawing. I hope that clarifies that. Trong, I know you were asking here. So when I say placed at 200, yes, that's 200, 400, 600. So it's just 200 apart. I don't. So it's from here it's 200. Let's say another from that one it's another 200. From that one it's just 200 space. The spacing between them is 200 millimeters. Okay. On the plan, there are one. Sorry, Hassan, what are you asking me?
Yes, sorry, Prof. There is on the side, there is a piece of rebars. What that? This is rebars?
Where? This exactly. One?
No, on the plan, on the plan.
On the plan view here?
Yes. No, on the side. Yeah, this part. Yeah.
No, it's just showing that, okay, this is the main rebar. This is the bottom rebar, right? or the one side rebar, and then these rebars start after, so it's showing that it starts from here. So usually there's like 50 millimeters apart. There's 50 millimeter spacing.
Sorry, Prof.
And then the rebar. Yes.
Sorry, Prof. Your sound is echo. I can't hear anything.
Can you hear me now?
Yes, it's better.
Yes. Okay.
Yeah.
So what I'm saying is usually there's this main bar. Okay. And then after that, you're going to have these rebars going from after this main one. Okay.
Yeah.
Going at 200 millimeters apart, but they usually start about 50, anywhere between 50 and 75. It depends on how they want them, how close they want them. And then they place them 200 millimeters apart after that. That's why just showing that what it's showing with these little two lines is the end of these type of rebars.
Okay.
Do you understand what I mean? Because if they didn't have that, means that you're going to say, I want this type of rebar, this main one, 200 millimeters apart, because they wouldn't understand. It would not be specific.
Okay. Is it important to draw it as we show it, or this is we can ignore this part?
This little line?
Yes.
So you're drawing it based on exactly how I asked you to draw, how you see that layout images. So it doesn't show, you don't even need to do all the text for it, the annotation.
Okay.
Okay.
Thank you very much.
You're welcome. You're very welcome. No problem. Okay. So that's it for rebar. Go back to work. Okay, guys, I'm going to go ahead and show everybody arraying. Okay, so if I want to, the reason for that is because we have the number of rebars. So if I want to place rebars, you know, and not have to draw them out or not have to measure out the distance, right? I'm going to just copy one of these. Okay. And I want to array them. So what I'm going to do is go into my array feature, or my array button. It's under where you do all your editing. So it's array number 6. And here it gives you options where you can array rectangular, polar, or along a path. Okay. So you have 2 options. You can do rectangular and then just say how many do you want per row or per column. So I just want 1, for example. Right? And then for the columns, I want 14. This is the top one. Or sorry, 15. See, I messed up again. And then the spacing, we want to have 200 millimeters. I think it was this one that I had to change. Okay. And then you just select your, and then it's going to ask you here to identify the element. So I pick the element. And then it automatically kind of shows you little dots to show you how they would look like. And if you go ahead away from it and select, just click on your mouse, it would automatically array the number that you wanted with the space that you wanted. Okay. Now you can also do it along a path. So it's pretty simple. Arraying is really simple because you can put information right in here as well. You can do it on an angle if you wanted. The path one gets a little bit sometimes tricky. And so if I want to array along a path, so the number, you can either say number or distance or both. So you can do both if you want. So you can say how many you want with a distance, or you can say, okay, you don't care about how many you want, but you want for a specific distance. So you want to say here 200. And then it's going to say your reference points. This is where it gets, I want to array, path, I'm going to identify the element. And when I do that, it automatically places the number, but you know, whatever amount of numbers, but as long as it has the distance that I looked at for 200. Okay. So again, for this one, you would have your rebar, your first one placed however way you want, and then you would click on array along path. You want to say a specific distance, right? And then you just select your first one based on here. So select your first one, and then you select your reference path. So you select your first point, and then you start going to your second point. Now, once you've done that, you know, you might have ones that are off. At that point, you can just erase the ones you don't need. So you can get rid of this one, for example. Okay. Any questions about arraying? It's pretty simple, but I thought I had shown it for this class. I guess I hadn't, so I apologize. So again, any questions? If no questions, we'll just keep going. Okay, class is over. I do this every time, I'm sorry. I hope you guys have a good evening. If you do have any questions, please email me and I will try to respond to those emails as soon as possible. And if we need to have meetings, we will set up a meeting, okay? Have a great evening. I'll see you guys next Tuesday. You as well, guys, in here, in Teams. Have a good evening. I'll see you guys next Tuesday. I am sorry if I haven't gotten to your email. If you do have a, sorry, if you have your question, if you do have a question, let me know by email, okay? Thanks. Bye.